Hello, everyone. Today we're working on adding and subtracting rational expressions. Um, so adding and subtracting fractions, essentially, but they'll be a little bit more complicated with some variables involved. First thing we need to talk about is the least common multiple. Least common multiple is important because we'll use that as our least common denominator when we're adding those fractions. So first of all, let's practice finding the least common multiple of 6y, 15x squared, 9y to the fourth. First thing we want to do is do a factor tree and basically see what the factors are. So 6xy, we have 2 times 3 times x times y. For 15, we have 3 times 5 times x times x. And for the 9, we get 3 times 3 times x times y, 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 y. 4 y's because it's y to the fourth. So when we're finding the least common multiple, we need something that all three of these pieces will go into evenly. So for the 6xy, we just need one of everything. So we need a 2, we need a 3, we need an x, we need a y. Now, when we look at the 15x squared, I already have the 3, so I don't need one of those. But I don't have a 5, so I need one of those. I already have one x here, so then I need one more x. And then when I get to the 9, I already have one 3, but I need another 3. I already have an x. I already have one y, but I'm going to need 1, 2, 3 more y's. So when I clean this up, what do I get? 2 times 3 times 5 times 3, what's that? 6, 30, 90. I've got an x, and I've got an x, so that's an x squared, and I've got a y, a y, a y, a y, that's y to the fourth. So my least common multiple, the smallest expression that all three of my values here will divide into evenly is 90x squared y to the fourth. So what do you notice? It was the highest exponent on the y. It was the highest exponent on the x. And then 90 is the smallest number that 6, 15, and 9 all go into evenly. Okay? All right, let's try another one. This one's a little different because we have to factor it differently. Find the least common multiple of these two expressions. So first thing we want to do is we want to factor it just like we did on the ones before. I'm going to take out a 4, and I'm left with a squared minus 3a minus 4. That's going to factor into a minus 4, and not x, but a plus 1. Over here, we can take an a out, and we're left with a squared minus 9a plus 20. And then we can factor that into a minus 5 and a minus 4. So when I go to get my least common multiple, I just take everything of the first one. So I'll have a 4, I'll have an a minus 4, and I'll have an a plus 1. And then when I look at the second one, I need another a. The a minus 5 I need, but then the a minus 4 I already have, so I don't have to do a second one. So that'll leave us with 4a times the a minus 4, the a plus 1, and the a minus 5. So I'll need all of that for the least common multiple. If these two values were in our denominator, then this would be our least common denominator. So adding and subtracting rational expressions, we need the least common denominator, which is our LCM that we just practiced. So let's figure out what the least common denominator is going to be here. So if I look at the 5, I'm going to write it off over here, the 5a cubed b squared and the 10ab. For the 10, I'll need a 2, a 5, an a, and a b. If we remember from before, we chose the highest power on each of these. So an a cubed is the highest power, a b squared is the highest power, and then what number do I need? Well, I need a 5, I need a 2, and I already took the 5, so I will need a 2, and a 5. 2 times 5 gives us 10. So our least common denominator is going to be 10a cubed b to the second. So I'm going to write that for my two denominators. Okay, so if I look and compare these two denominators, what's missing? Well, hold on. I'm going to put the 4 up there that I already had, and then I'm going to say, well, what's missing? I'm missing 5 times what gets me 10, a 2. I have the full a cubed. I have the full b squared, so I'm only missing the 2. On the second fraction, I had the 9c already. What's missing? I have the 10. I have an a, but I needed an a cubed, so I need an a squared. I have a b, but I needed a b squared, so I need another b. So then what? Clean up the numerator. Clean up the numerator over here. I'm just going to rewrite it so it's in alphabetical order. And then our denominator, when we add fractions, is the same. So our answer looks like that. Let's try another one. First thing we're going to do is we're going to factor. So I have an x squared minus x minus 6, and I have a 5x plus 10 for my denominators. If I factor the first one, I get x minus 3 and an x plus 2. If I factor the next one, I get 5 times the quantity x plus 2. So for my LCD, I'll need the x minus 3. I'll need the x plus 2. Then look at the second one. I'm going to need the 5. Put that out front. And I need an x plus 2, but I already have an x plus 2, so I don't have to list it a second time. So this will be my common denominator. So I'm going to write my two fractions. I'm going to write out the denominator that I need for both. Now, if you remember, this one factored into an x minus 3 and an x plus 2. This one factored into a 5 times an x plus 2. So I compare my denominators and I say, well, what's missing? I already had the x minus 1 on top. What's missing? I'm missing the 5. I've got the x minus 3's. I've got the x plus 2's, so I'm only missing the 5. On the second fraction, I had a 4 originally, and then I say, what's missing? Well, I have the 5. I have the x plus 2, so I'm missing the x minus 3. Then we just clean it up. Distribute, that gives me 5x minus 5. Now be careful with this negative here. Think of it as plus negative 4. Distribute that negative 4 through. That'll be negative 4x plus 12, and that's all over the same denominator. So what does that equal? 5x minus 4x is x. Negative 5 plus 12 is 7. And then I usually just leave the denominator factored so it looks nice and neat. So we're left with x plus 7 over 5 times quantity x minus 3 times quantity x plus 2. Okay, so it's all about finding this least common denominator and then asking yourself the question, what's missing from my original denominator to my new denominator? Second kind of problem we'll have here is a complex fraction. Now I know I've told you before, complex usually means hard. So we're going to have to take our time on these kind. So first thing we're going to do is we're going to focus on the numerator. What is the least common denominator of the numerator? Well, this 1 is really over 1. Okay, so I need a 1, I need an x, so my least common denominator is x. Then how about of the denominator? So looking at the blue, what's my least common denominator there? Well, I need a y and I need an x, so my least common denominator is x times y. So we're going to focus on the numerator and then we'll focus on the denominator. So if I focus on the numerator, I said that my least common denominator was x. So it looks like this. Now, this second fraction matched already, had the same denominator. I wasn't missing anything, so the y will stay. On the first fraction, the 1 over 1, or 1, what's missing? I was missing the x, so I'll have an x on top. So then when I go to simplify that, I will have x minus y over x. Now, for the denominator, our denominator, the least common denominator, was x times y. So what's missing in the first fraction? I have a y already, so I'm missing the x. What's missing in the second fraction? Whoops, this is supposed to be plus. What's missing in the second fraction? I already have the x's matching, so I'm missing the y. Combine those together, we get x plus y over xy. Now this becomes like the ones that we did yesterday, where this is really the numerator divided by the denominator. Okay, just writing it sideways instead of vertically. So what does that really mean? That means we take the numerator and we multiply it by the reciprocal of the denominator. So we flip that second fraction, or we flip that denominator. And then we just clean it up. Well, when we do that, the x's cancel. Nothing else cancels. So we're left with y times the quantity x minus y over x plus y. And if you need to rewatch that, rewind it and look at it one more time. Okay, that's one option of how to do complex fractions. We're going to try a second method in the next problem. Okay, so this one we are going to find the least common denominator of both the numerator and the denominator. So if we look here, this 1 is really over a 1. So what do I need? I need a 1. Doesn't really do anything for me. I need an x. I need a y. And I need an x, but I already have it, so I don't have to list it again. So our least common denominator is going to be xy. Okay? So what are we going to do? Well, we've got our numerator and we've got our denominator. So our numerator will be xy, something xy. Our denominator will be over xy minus something xy. Now on the first one, we had a 1 up here. What are we missing? We're missing both the x and the y, so I will need to add in an x and a y. On the second fraction here, the 2 we already had. What was missing from the denominator? We were missing a y, so we'll have to put that in there. Then on the bottom fractions, we already had the 3. What's missing between the denominator? Well, we already have a y, so we're missing an x. And on the second fraction, we already had the 4 there. If we compare the denominators, I had an x already. So what's missing? I'm missing the y. All right, so now then this is equal to, in the top we get xy plus 2y over xy divided by, and in the bottom we get 3x minus 4y over xy. Now remember, this is written vertically, so if we write it horizontally, we get that. But then what? We have to multiply by the reciprocal. So then we're really going to multiply by the reciprocal, which then those denominators entirely cancel out, and we're left with xy plus 2y over 3x minus 4y. And I've got 30 seconds to spare, so sorry, I know that was quick at the end. But we're going to divide by the denominator, which really means multiply by the reciprocal. So when I take this times this, because my denominators match, they cancel entirely. Okay, so try the homework tonight, and we'll regroup the next time I see you, and we'll go over any questions you have on the homework. Okay, peace out, guys. Have a nice night. Bye.